So now that we focused on our integrals through the trigonometric methods, we can focus on trig substitution because we have all the tools to handle them. So this one is actually a good test for us because it shows us that the best integral technique is not necessarily the trig substitution. So whenever you see the radical, that normally means that you should use a trig substitution, and especially when you see the 1 plus x squared, it means that x should probably be tangent of theta. But here we can actually use a u substitution because our derivative of this function is on top, right? So this is the derivative of this function, which means that we can take that our u is equal to 1 plus x squared, our du is equal to 2x dx, right? Then we plug that in, we get that our integral of x over u to the 1/2, 1 over 2x du, we'll cross out our x's. That'll evaluate to 1 over 2, the integral of u to the negative 1/2, right? We're just moving our u to the top, du. Now we use our power rule. We get 1/2 times this integral, right? We're going to increase our power by 1 and then divide by that increased power. So we're going to get u to the 1/2 times 1 over 1 divided by 2. These halves are going to cancel. We're going to get u to the 1/2 power plus our constant. Plugging in u, remember it was 1 plus x squared. We get the square root of 1 plus x squared plus c. Now we can do a trig substitution. It's just going to be a lot harder, right? So this is why it's important to recognize when a u substitution is best and when a trig substitution is best. So here we're going to choose that x is equal to tangent theta, right? Dx is going to be equal to secant squared theta. So we're going to get x tan theta, right? And then we're going to get our dx is equal to secant squared theta, d theta, right? Then we're going to get 1 over 1 plus tangent squared theta. Now, we need to use our trig identities here, right? The 1 plus tangent squared theta evaluates the secant squared theta, and then that square root of the secant squared theta will make it a secant theta. So we're going to have that this integral becomes tangent theta, secant squared theta d theta over secant theta. Our powers are going to cross out. We're going to get that this integral is tangent theta, secant theta, d theta. Now we could recognize that this is the derivative of a function, and then we'll realize what the integral of it is. Or we could just, do the work ourselves, and we'll see what the final answer is. So here it's good to turn each of these into cosines and sines, and that'll simplify our problem. This would be sine of x, cosine of x times a 1 over cosine of x dx. And so here it's easy to see that there's a trig substitution, or a u substitution that we can make, right? U is equal to cosine of x, and then our derivative of cosine of x is on top here. So we have that this is going to come out to, right, u is equal to cosine of x, du is equal to negative sine of x, right? So then we get negative the integral of 1 over u squared du, right? And then we're going to again do another power rule. So we get negative 1 times the integral of u to the negative 2 du. Power rule, increase by 1, then divide by it. So we're going to do a negative 1, u to the negative 1. We divide by that negative 1, so it's 1 over negative 1. Right? These negative 1s are going to cancel. We just get u to the negative first power. This is going to come out to, right, remember our u was cosine of x, so it's going to come out to 1 over cosine of x, which is equal to secant of x, right? And then we have to draw out our secant theta. Then we have to draw out our triangle, right? Our original theta was equal to arctangent of x over 1, right? The arctangent of x over 1, that's going to be this, right? For theta is here, right? X over 1, and then we have x squared plus 1. Right, so if we take the secant of this angle, that's going to be the hypotenuse over the adjacent, right? Because the cosine is the adjacent over the hypotenuse, but we're going to take the reciprocal of that. So it's going to be x squared plus 1 over 1. So then we get that the secant of arctangent of x is going to be x squared plus 1. And then we add our constant. So we get the same result, but it's definitely not the easiest method.